Hello my dear friends, I welcome back you to my YouTube channel Beginners Chemistry, where you can learn the chemistry in the easy manner. Okay, in our Beginners Chemistry already we have started the series of the lectures, that is basics chemistry. In our basic chemistry already we have studied about the basic number 1, basic number 2 and the basic number 3. Already it are there in our YouTube channel. Better if you have not seen, first you go and see those videos, because this video which we are doing, it is only on the basis of summary. I hope you know what is the meaning of the summary. Summary in the sense, what this is just quick recap. The one who is preparing for the exam or for the quick revision, the one who has completed all the basics, for those basics who has completed, this is just for the recap. For the fast revision type, this summary season will be helpful for us. So let's start our lecture. Now we'll see how the chemistry will be related to our modern life. Now where we are going to see our chemistry in our modern life, we used to see in the form of H2O solid, in the form of ice. Next, in the form of H2O liquid, we used to see as a water. Next, we used to see generally daily in our daily life, we used to use that sugar, right? That sugar is nothing but sucrose, C12, H22, O11. Clear? And the another essential we are going to see, that is amino acids. Clear? Next, where we are going to see our chemistry in the fertilizers also. In the fertilizers, the main ingredient that we are going to see and the first organic compound, that is urea, NH2 C double bond O NH2. Clear? Next, the food that we are going to mix to be easy digestive for the cows or the buffaloes. Clear? For that one, the main ingredient we used to mix, that is a KCl. Next, and other elements that we are going to use in our fertilizers, the main one, nitrogen, phosphorus, potassium, we used to use the iron, we used to use the chlorine, we used to use the zinc. Clear? These are the some essential compounds that we are going to see in our daily life of the, which one we used to see in our daily life and we used to use in our fertilizers also. Okay, next, how the chemistry will play a very crucial role in the medicines also we have seen. Now you see, first very crucial role in the corona's time we have used, that is propane to ol. This is the propane to ol. This should be the dilute. This dilute propane to ol we used to in the which one we used to use in our sanitizers. Okay. Next, this is a cisplatin. Clear? This is a cisplatin. This cisplatin where we are going to use now. This cisplatin we are using in the treatment of the cancers. We are using in the treatment of the cancer. Next one, this is a azidothymidine. Sir, where we will use this tablet, sir? We used to use in the treatment of HIV and the AIDS. Clear? Next, this is a one type of the tablet and we are going to see the reaction of this one in our upcoming classes. Clear? This one is a aspirin. This is a aspirin. Clear? Now in this manner where the chemistry will be related, or the chemistry will be related to our modern life. Clear? Next, we are going to see physical classification of the matter, how the matter has been classified. Clear? This already we have studied. Now what is the meaning of the matter? We know this is a solid. Solid, when we heat, see this is a solid, right? For the solid, if you heat, what it will happen? This it will be converted into liquid. Again liquid, if you heat, what it will happen? It will be converted into gaseous. Clear? You can see here, solid, it is converting into the liquid. That process we call it as a melting. That process we call it as a melting. Again that liquid, again it is converting into the gaseous, and that process we call it as a evaporation. Clear? That process we call it as evaporation. Done. Now here you can see, this is a solid particles. This is a solid particles. When the solid particles, if we are heating, it is converting into the liquid particles. You can see these are the liquid particles, and when we have heated, again it is moving to the gaseous particles. you can see here, these solid particles are tightly packed here. These are tightly packed. It is having the fixed shape. Now, when it comes to the liquid compared to the solid, it is somewhat having high space compared to the solid. Now, what is the shape of the liquid? If I ask, in which shape it is present, that is the shape of the liquid. If suppose if it is present in the bottle, what is the shape of that liquid? That bottle. Clear? Gaseous having the very free, right? Gaseous particles are far away from each other and they are free to each other, and there is no any attraction force because those are far away from them. The volume occupied by the gas will be very high compared to the liquid and compared to the solid. Clear? Then directly, if you want to convert the solid into the gas, directly what you have to do, you want to convert that solid into the gas. That process we call it as a sublimation. That process we call it as a sublimation. Clear? Example, sir. Can you give me the one example for the sublimation, sir? The example for the sublimation is camphor. We used to see in in the temples we used to see the priest used to use, right, for the pray to the god. Clear? Now next one, the gas direct that is converted into the solid, that we call it as a deposition. Next, gas that is converted into the liquid, we call it as a condensation, and that liquid that is converted into the solid, that we call it as a freezing. Clear? These are the some physical classification of the matter. Clear? Now next we are going to see the chemical classification of the matter, how the matter has been classified. Clear? In the chemical classification of the matter, this matter has been divided into the pure substance and is a mixture. In this mixture, this has been divided into two types. One is a homogeneous mixture, one is a heterogeneous mixture. One is a homogeneous mixture, one is a heterogeneous mixture. Then next after that, element. This element, what is the meaning of the element? That element, it will contain, it's a pure atoms. Only the pure atoms it will be present in the element. If I say sodium element, in that sodium element, what it will be there? The pure sodium atoms will be present. Pure sodium atoms will be present. Again, these elements has been classified into the metals. Metals mainly here, these are the metals, metalloids and the non-metals. Already I explained very clearly about this metals, metalloids and the non-metals in our basic chemistry lecture number 3. If you have not watched that lecture, better you go and watch that lecture. Clear? Next, here this next one, the compounds, we are having the inorganic compounds and we are having the organic compounds. That because we are going to study the inorganic chemistry, we are going to study about the organic chemistry. In our upcoming classes, we are going to see what are the inorganic and what is the organic and what are those compounds. Okay. Next, we are going to see what are the heterogeneous. Heterogeneous means what is the meaning of the heterogeneous and what is the meaning of the homogeneous. Best example for you, our daily life. What is a heterogeneous and what is a homogeneous? Heterogeneous means same phase. What it should be there? Same phase it should be there. Best example, if you mix the sugar in the water, this is water, and if you mix the sugar, if you add the sugar into this H2O and if you shake it, what it will happen? The sugar and the H2O will become same phase. That type of the mixture we will call it as a homogeneous mixture. Now what is the meaning of heterogeneous mixture? Heterogeneous mixture means, now best example, we'll take the which one? Same H2O. H2O will take. In this H2O, what I'm adding? I'm adding some sand. If I add the sand, what will happen? The sand particles will be deposited here, right? Will be settled down. Clear? Now you can see H2O is a liquid and the sand particle is a solid. Different phase of the mixture it is there, right? Clear? That's the reason that we will call it as a heterogeneous mixture. So these terms will play very important role. Clear? These are the basics only. These terms will play very crucial role in the solving of the questions also. So better these terms are very important and try to remember. Clear? Now here Heterogeneous. Heterogeneous example, sir. If I was taking the CaCO3, okay, if I was taking CaCO3, this CaCO3, if I was heated, how it will convert? This is CaCO3 solid. It will be converted into CaO solid plus CO2 gas. Clear? You can see one solid we have taken. With the solid, with the help of the solid, we are getting solid plus gas. Clear? That's the reason this is heterogeneous. Next example, sir. Better if you take the I2 solid converted into I2 gas. Now, I said the camphor, right? Camphor solid, if you heat it directly, it will be converted into camphor gas. Clear? These will comes under the heterogeneous. Now, what is the meaning of the homogeneous? Homogeneous means same phase it should be there, right? What are the same phase we are having? Example, that is, if you take the PCl5, if you heat it, it will be converted into PCl3 gas and Cl2 gas. Clear? These are the some examples we are having for the next homogeneous. These are the homogeneous, right? Now, in this homogeneous, next one, H2 gas and the I2 gas gives rise to 2HI gas. Clear? Now, this is also one example for the which one? Homogeneous mixture, and this is a heterogeneous. Heterogeneous means different phases are there. Homogeneous means same phase are there. Nothing but same. Okay. Next. Next we are going to see where the chemistry has been started. Now, here that we are going to start about the atom. Here we are talking about the atom. What is the atom? The smallest particle of an element which may or may not have independent existence but always takes place in the chemical reaction is called the atom. See, here what is the meaning of the atom means? Here whatever you have studied in your lower classes and what we are going to study in our higher classes is entirely different. But this is about only for the basics, right? Better we'll go with the basics only. Clear? Now, we know atom, it contains proton positive charge and the neutron neutral charge and the electron negative charge. See, this is electron negative charge and proton positive charge and the neutron neutral charge is revolving around it. Clear? Revolving around it, that we have studied. Now, in this what we are going to see, best example to try to well recognized about the atom. I will take the one family. Family is a just best example for us. In this family, father, mother, kid 1, kid 2. Here the father, mother, kid 1 is 5 years of age, kid 2 is, let's take 2 years of age. Done. This is 2 years. Now, without who is the atom, if I ask in the family, means you can say that, sir, the smallest one, this kid 2 is our atom. This kid 2 our atom. This kid 2 having any independent existence? No. Without dependent father or mother, he cannot go outside, he cannot eat. Clear? He cannot eat. This, right? He cannot eat or he cannot see. Now, here this one is a atom. Who is the atom here? This kid 2 is our atom. Clear? Now, next comes to the molecule. What is the meaning of the molecule? What is the meaning of the molecule? Molecule means the smallest particle which is having independent existence in its nature. Best example, same. Again, we'll go with the family example only. Family. Now, father, mother, kid 1, kid 2. Okay. Now, father age is 60 will take. Mother's age is 55 will take. Now, kid age is something around 20 will take. Now, kid 2 age will take it as 18. Now, who is the molecule if I ask? Directly you will say that, sir, Kid2 is a molecule. What I said molecule? The smallest particle which is having the independent existence in the nature is known as a molecule, we have said. Clear? Already this Kid2 is the smallest and he is having the independent existence because already he has become the major. 18 above means 18 plus will take better. Now this is he has become the major in the sense already he is having the independent existence. Independent existence means without the help of the father or mother he can do its own works. Clear? That's the reason this is our molecule, means independent existence which are having, those are the molecules. Now we'll see here that example I will give you more clearly. Hydrogen is a atom. Hydrogen is a atom. But hydrogen individually it will not exist in the nature. It will not exist in the nature, but it will be exist in the nature as a He2 molecule. He2 molecule. Clear? Hydrogen is one atom and another atom. These two combinedly will be exist in the nature as a He2 molecule. But when it comes to the He, this He will be having the independent existence in the nature and it will be exist as a He molecule. So there is no any He2 molecule. Okay, it is having the independent existence and it will be exist in the nature as which one? It will be exist in the nature as He only. Clear? That is the difference between the atom and the molecule. Molecule which is having the independent existence. Now this one it is not having any independent existence. Clear? It will be exist in the nature as He2 molecule. It will be exist in the nature as which one? It will be exist in the nature as no, it will be exist in the nature as H. Now we'll see here some examples. CO2, this is a molecule, and NH3 molecule. Next CO2 molecule, NH3 molecule, and we are going to see some H2SO4 molecule. If suppose if they have given, if they ask how many atoms are there, how many atoms are there in this compound if they ask, and the total number of atoms present in this compound if they ask. First, this compound contain one carbon atom and two oxygen atoms, right? One carbon atom and two oxygen atoms. These two combinedly will give you total 3 atoms. Total 3 atoms. Done? Now, when it comes to here in this compound we are having one nitrogen atom and 3 hydrogen atoms, right? These two combines will give you 4 atoms in the compounds. Clear? If I ask how many atoms are there in this compound, if I ask 2 hydrogen atom, 1 sulfur atom and 4 oxygen atom, totally combines to give 2 plus 1 3, 3 plus 4, total 7 atoms are there in this compound. Total 7 atoms are there in this compound. Clear? Is it clear? I hope it is clear for you. Atom means independent existence in the nature. Molecule means smallest particle which is having, which does not having independent existence is atom. Which having the independent existence is molecule. Clear? Next. Here hydrogen will not exist in the nature as hydrogen. It will be exist in the nature as He2. H2. And He, it will be exist in the nature and it is existed in the nature as He. Clear? Now, next we are going to move to the ions. What is the meaning of the ions? How the ions will form? Ions, when we can say the ions. Before going to the ions, here already we have studied about the atom. Atom, what? Atom, it contains the nucleus, positive charge proton and the neutral charge neutron. This we call it as a nucleus, and the electrons revolving around in it. This we have studied. This is a neutral atom. When we can say the atom is neutral? Here, how many protons are there? How many protons are there in the nucleus? That many electrons if it is present, then that atom we will call it as a neutral. Then that atom we call it as a neutral. You can see this electron, how many protons are there? You can see here. One proton you can see here. One proton you are going to see here. This is one proton. Here one proton. One proton, one proton. How many? 4 protons are there. How many electrons are there? Total 4 electrons are there. So that's the reason this is a neutral atom. This is neutral atom. Protons, how many are there in the nucleus, will be equal to the how many electrons are there, then the atom is neutral. Then next comes to the cation. What is the meaning of the cation? Cation will form when the one electron is less compared to the proton. See here we are, how many protons we are having? 4 protons we are having. In comparison with the 4 protons, how many electrons we are having? Only 3. So that's the reason one loss of electron, by the loss of electron will form the which one? Cation. Okay, next anion. What is the meaning of the anion? In comparison with the proton, one extra or how many extra electron, it may be 1 or 2 or 3. Clear? Now here you can see how many protons we are having. 4 protons we are having, but how many electrons we are having? 5 electrons we are having, right? Now compared to the proton, if the electrons are high, so anion. Compared to the proton, if electrons are less, compared to the proton, if the electrons are less, cation. Sir, I did not understand. Can you give me more clearly? Okay, I will give you more clearly, and we will go with the well-known example for you. So what I was saying, how the cation will form. First, cation, how the cation will form? Loss of electron will leads to give, loss of electron leads to give the cation. Clear? Now anion, gain of electron leads to give the anion. Loss of electron leads to give the cation. Gain of electron leads to give the which one? Anion. Sir, with a general example, can you give me? Okay, I will give you with a general example. General example, if I take the sodium, it is having atomic number is 11. Clear? 11 means this sodium contain 11 how many protons as well as 11 electrons. From this sodium, if I was removed 1 electron, it will get how many electrons? This is a representation when we remove the electron. This one also, again this one we will call it also oxidation. I will explain very clearly, but as of now you remember. Clear? This is a sodium. By the loss of 1 electron, this is representation of the loss of electron. Now you see, loss of electron, before sodium it is contain 11 protons will be equal to 11 electrons. Now this Na plus, this plus indicates that loss of electron. In our chemistry, if the plus and the negative, if you see, those are not the addition and those are not the subtractions. Clear? Those are positive means loss of electron, negative means gain of electron. When you come to the chemistry, please blindly remember that one. Okay. Now this is Na plus, right? Now in this Na plus we are having the 11 protons, and how many electrons are there? Only 10 electrons are there, because 1 electron is lost. This is electron is lost, and this process we call it as a oxidation. Now when it comes to which one? Gain of electrons. How to write the gain of electron? Better we'll go with the Cl. This is Cl. Now this Cl, by taking 1 electron, now it will be converted into Cl minus. This is converted into Cl minus. Before this Cl having how many electrons? 17 protons and 17 electrons. By taking 1 electron, now it has converted total. Now how many electrons are there? Total 18 electrons. And this process we will call it as a reduction. This process we will call it as a reduction. Cation is loss of electron, anion is gain of electron. So the loss of electron and that process, when any atom, if it is losing that electron, and that process we call it as oxidation. If any atom or compound, if it is gaining the electron, and that process we call it as a reduction. Clear? Done? Now we'll move to the very basic thing about the periodic table. Now about the periodic table, just I will give you just brief orientation and what are the compounds you have to, or what are the elements you have to remember in the periodic table. See, already we know the periodic table, it is having the how many elements? 118 elements. In that 118 elements, it has been divided into 4 blocks. One is S, one is P, one is D, and one is a F. Clear? That we have seen here. But sir, why you are saying the periodic table here itself? Why I was saying the periodic table here itself? Because here, just before going to understand how to represent the elements, basic elements, up to 30. Up to 30, the basic elements you have to remember. Up to basic elements, what are the basic elements? You can see here 1 to this 30. Clear? These are the some basic elements you have to remember. Just to understand more detailedly, more clearly, we are going to study about all the elements, but now we are studying the only basics, right? At least up to these basics, that remembering of the 30 elements is must and should. Clear? What are that? First is hydrogen, second is helium, next lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Clear? Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Clear? Its atomic number as well as its element's name you have to remember. Clear? Done. Now we are going to the another one, that is symbol of an element. How to represent the symbol of an element? If suppose if they have given the element, by seeing the representation, by seeing that representation, we can say how to represent the any element. Here basic representation of the element will be X. What is the meaning of the X? X is a symbol of an element. Symbol of element. Clear? Here they will give you Z. What this Z represent? This is atomic number of that element. Atomic number of that element. And they will give you A here. What is this A represent? This is a mass number. Mass number of that atom or mass number of that element. Clear? Now, sir, can you give me any general example with the well-known example for us? Okay, I will give you, don't worry. Now, here, this is a sodium. Sodium, its atomic number is 11 and its atomic mass is 23. Sir, it is having the atomic number 11. If you add it also, it should be become 22. Sir, why it is becoming the 23? Okay, why it is becoming the 23? Now I will explain clearly. Okay. Next, if suppose chlorine, if I go, its atomic number is 70. If you add, it is having, if you double, its atomic mass should become 34. But it is having some exception, and its atomic mass is 35.5. Next, if you take the Al atomic number is 13. If you add doubled it, it will become 26. But it is having some 27. Majority of the cases, some exceptions also will be there. Majority of the cases, even atomic number will have the, if you doubled, even atomic number containing elements, if you doubled, that will be its which one? It's a atomic mass for the even number containing elements. But odd number, it is having some exceptions. Okay. Now, here this is a representation of the elements. In this manner we will represent. This is atomic mass, this is atomic number. Clear? Now here next we are going to calculate number of protons, number of neutrons and the number of electrons for the given species. If one species, if they have given, sir, how to calculate the number of protons, number of neutrons and the number of electrons? Now you see here, first how to calculate number of neutrons, I will explain. Protons and the electrons, already I explained you. What? If you take any neutral atom, if 2 protons are there, 2 electrons it should be there. 2 electrons it should be there. If 2 protons are there, why the 2 electrons it should be there? Because to become atom neutral. Here the positive charge is there and these are negative charges. This positive charge and the negative charge. If the positive charge is there, to stabilize that positive charge, one negative charge it should be there. For the positive charge, if you remove one electron, 2 positive charges are there. 1 electron is there. 1 proton is unbalanced, right? That unbalanced proton will be very high reactive. That very high reactive. What it will do? It will see the electrons. It will see the electrons. Where the electrons is there? where the electrons are there. So it will be very high reactive. That's the reason if hydrogen atom, if you say the proton is a very high reactive. In the H2O also, proton is a very high reactive, we used to say. Why? Because for the proton, one electron has been lost. For that single proton, it should need the electron. So it will search for the electrons. It will be very high reactive. That's the reason to make the atom neutral, what we have to make? We have to make the, which one? How many protons are there? That many electrons it should be there. Now here, so can I say Z atomic number will be equal to the protons. How many protons are there? That will be equal to its electrons. This is clear. So where we will get the difference? Where the more the difference we are going to see in the neutrons case. In the neutrons case, how we will see? First, how to calculate the neutrons. To calculate the neutrons, first of all, here atomic mass we will calculate on the basis of protons plus neutrons. Protons plus neutrons will give you the which one? Atomic mass. So if you want to calculate the neutrons is equal to atomic mass minus proton. Atomic mass minus proton. Done. Clear? Now you see here, best example, I will go with the first hydrogen. Representation of the hydrogen will be in this manner, 1 1. So if I ask number of protons for the hydrogen, atomic number will be the proton 1. Number of electron, it's a number of proton will be equal to electrons 1. If I ask neutrons are 0. This is very very important. Hydrogen will never and ever will have the neutrons. How the hydrogen will never have the neutrons? Because its atomic mass is 1, proton is 1, 1 minus 1 will be the 0. 1 minus 1 will be the 0. Clear? I hope it is clear for you. Now, if suppose any molecules, if they have given, molecules or compounds if they have given, so how to identify the number of protons, number of neutrons and the number of electrons? Here you can see. Here you got it right. What atomic number will be equal to number of protons, and that number of protons will be equal to the electrons. Then atomic mass or mass number will be equal to protons plus neutrons. That's the reason sodium for the sodium if they have given sodium if they have given sodium representation of the element is in this manner. For this sodium, how many protons are there, how many neutrons are there, how many electrons are there? If I ask, atomic number is 11, right? So the protons will be 11 and electrons will be 11, same. And if suppose if I ask how many neutrons are there, neutrons will be atomic mass minus protons, right? 23 minus 11 will give you the 12 neutrons. Okay, done. Now if suppose any molecule if they have given, better we'll go with the one molecule, H2O molecule if they have given. In this H2O molecule, number of protons, number of neutrons and the number of electrons if they ask. For that one, what you have to do? Here, first how many hydrogens we are having? First divide this H2O molecule into atoms. 2 hydrogen atoms plus 1 oxygen atom. This 2 hydrogen atom contain protons. 2 protons because 1 hydrogen atom contain 1 proton. But we are having here 2, right? Here we are having 2. So 2 protons, and here how many oxygens we are having? 1 oxygen. 1 oxygen atomic number, oxygen mass number is 18 and atomic number is 8. So here atomic number is 8, right? So oxygen's protons will be 8. Total it will give you 10. Done. Comes to the electron. Electrons also same. Number of protons will be equal to number of electrons. 2, 8, it will be 10. Clear? Neutrons case you come. This is very very important. If you comes to the neutrons case, in this neutrons case, already I explained you. Hydrogen neutrons are 0. 2 into 0 also 0. And when it comes to the oxygen, how to calculate the oxygen neutron? Atomic mass is 8. Atomic mass is 16. Atomic number is 8. So neutrons will be 16 minus 8, right? It will give you 8. So 8. Number of neutrons are 8. Clear? This is about the, if they have given the molecule, how to identify the proton, electron and neutron. Sir, just now you have said about the, which one? Sir, you have said about the cation and anion. If suppose the cation or anion, if they have given, sir, how to identify the number of proton, how to identify the number of neutron and how to identify the number of electrons for that one, sir? Okay, I will explain, don't worry. Now, for the cation first. Cation and the anion. For the cation and the anion. Anion first I was taking for the O2 minus and F minus. For the cation I was taking for the Na plus and Mg plus 2. Here for this Na plus ion or this Na plus cation, how many protons are there? I said protons will be fixed. Atomic number will be equal to the protons. Protons will be equal to 11. But electrons will be different. Why the electrons will be different? Already I said this ion will form, cation will be formed by the loss of electron, right? Normally, if the atom is neutral, 11 protons are there, 11 electrons it should be there. But what it has happened now? One electron we have removed, right? One electron we have removed. So that one compared to the 11 electrons, one electron lost means total electrons will be 10. Before 11 electrons and 11 protons it should be there. One electron we have removed. So the electrons will be 10. Now neutrons will be same. 23 minus how much? 11. That will give you the 12. Done. Comes to the Mg plus 2. What this plus 2 indicates here? This plus 2 indicates that 2 electrons has been lost from the magnesium. Now protons will be 12. Magnesium atomic number will be 12. And electrons. From the 12 we have removed the 2, right? This 2 indicates that loss of electron. So 2 removed means 10. And neutron. Neutrons will be magnesium 24, 12. So if you minus, neutrons will be 12. Clear? Comes to the oxygen. Oxygen case, this anion will be formed on the basis of which one? It will be formed on the basis of which one, Amma? It will be formed on the basis of gain of electron, right? Here how many electron it has gained? 2 electrons it has gained. It has gained the 2 electrons. So first proton. Proton will be its atomic number 8. And electrons. Electrons normally number of protons will be equal to number of electrons. Number of protons will be equal to number of electrons. But 8 electrons it should be there. But we have gained the 2 electrons, right? Total it has become 10. And the protons. Protons will be already we know representation of the oxygen will be in this manner. 8, 16. 16 minus 8. Clear? Neutrons will be equal to what? Atomic mass minus atomic number. So it will be 16. Comes to the fluorine case. Fluorine representation of the element will be 19 and 9. 19 and the 9. See, proton will be equal to 9. Electrons will be equal to, it should be 9 electrons. But F minus, right? 1 electron gained, right? So total 10. Protons will be equal to how many? Sorry, neutrons will be equal to 19 minus 9. It will give you 10. It will give you the 10. Clear? Done. How to calculate the number of protons, number of neutrons and the number of electrons in the atom if they have given the molecule, if they have given the cation, if they have given the anion. In that manner we have to study. Clear? Next. Before going to the study about the some basics of the periodic table, first we have to know about the atom. In your lower classes I know you have studied this atom. What you have studied? Atom. Atom, it contains the proton and the neutron and it contains the orbits, right? Or it contains the shells, right? What are the shell? The first shell is a K shell, second shell is a L shell and the third shell is a M shell. That we have studied. And K shell can accommodate the 2 electrons and L shell can accommodate the 8 electrons and M shell can accommodate the 18 electrons. Okay? This is some basic idea of the atom that we have studied. Atom, protons plus neutron and electrons revolving around it. And we are having the different orbits, right? One is K shell, L shell, M shell. K shell can accommodate 2 electrons, L can accommodate 8 and the M can accommodate 18 electrons. Clear? Now comes to the periodic table. Sir, already you have explained about the periodic table. Why you have came here again? Why you are explaining? Beta, I will explain why, because now listen. Here in the periodic table, why we are going to study and what we are going to see, you know, in this periodic table, if you go from the left to right, from year to year, what it is happening? When you go from the top to bottom, what it is happening? Now, in our periodic table, how many elements we are having? 118. This elements has been divided into 7 periods. You can see first period, second, third, fourth, fifth, sixth, seventh. Clear? And groups 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Total 7 periods and 18 groups. So what are the difference between the 7 periods and the 18 groups? Here what we are going to see, left to right if you move, what it will be happen to the atomic size. Left to right if you move in the periodic table, atomic size will be decreased. Left to right, atomic size will be decreased only up to fluorine. Only up to the fluorine. Up to the fluorine only it will be decreased, but compared to the fluorine and the neon, it is having some exceptional atomic size. Why it is having, I will explain very clearly when we start the classification of periodic table. But up to now, you just remember. Okay? I don't want to make you more confused. Here, you may, already I made you confused, but I will explain very clearly in the classification of periodic table stats, because this is only basics. So we will discuss only the basics. Okay? Now, here left to right when we move, atomic size decrease up to where? Fluorine. Clear? Now top to bottom, if you go, what happens? Top to bottom if you go from the left to right, size is decreasing. If you go from the top to bottom, what is happening? Size is increasing. Why the size is increasing? Why the size is decreasing? Because you can see when you go from the, now if you go from the left to right, first I will go for the lithium, next is a beryllium, directly I will go for the fluorine, because comparison will see. Lithium it is 3 atomic number, beryllium it is 4, and what? Fluorine it is 9. Now if you draw the atomic or atom of the lithium, 3 is the atomic number, means how many protons will be there? Already I explained, 3 protons. Done. How many electrons lithium should have? 3 electrons it should have. So now then 3 electrons, how we can accommodate? First shell can accommodate only 2 electrons. Already K shell can accommodate only 2 electrons. And next shell, this is a K shell, and the next one is a L shell, right? L shell can accommodate how many electrons? 8 electrons. But in the 8 electrons, we should accommodate only 3. So already 2 we filled in the K, and the next electron we should go to the L, right? Clear? Now in that K, 1, done. Comes to the beryllium case. Beryllium case, how many protons are there? 4 protons are there. Why? Atomic number is 4. Now comes to the shells. First shell and comes to the second shell. Now here first shell can accommodate 2, second shell can accommodate 2. Now compared to the beryllium and lithium is having the higher size than the beryllium. Why? You can see here we are having only 3 positive charges, 3 protons. Here you can see, here we are having the 4 protons. Now here 3 proton is having the higher charge, or 4 protons are having the higher charge. See, 3 protons is having, compared to the 3, 4 is having the higher number, right? Compared to the 3, 4 is having the higher number. Means 4 means 4 protons are having higher capacity to pull the electrons towards it. Compared to the 3, 4 people are pulling, you are having the 3 people, and if you do the tug of war, 3 people are pulling and the 4 people are pulling. Who will win? Obviously the 4. Same thing here also, 4 protons are pulling the electrons. 4 protons are pulling the electrons towards itself, means what it will happen to this shell size? shell size will be, attraction means shell size will be decreased. Here only the 3 is there, only 3 protons are there. Comparative with the beryllium, here the proton charge is less, so attraction is also less, so size will be more compared to the beryllium. Comes to the fluorine case. Fluorine case, total 9 protons will be there and 9 electrons will be there in the 2 shells. 1, 2 will be accommodated in the K, and L can accommodate 3, here 4, here 5, here 6, here 7, here 8, and here it is a 9. Done. This is about the fluorine atom. Now for the fluorine case, you can see 9 are there, right? So 9 protons will express the high nuclear charge. So more than 9 people are pulling the electrons towards itself, means so very fastly that atom will be shrink. Very fastly it will be shrink, right? Very fastly it will be become very less size compared to the beryllium. So that's the reason when we move from the left to right, atomic size will be decreased. Clear? Now when we go from the top to bottom, what happens? If you go from the top to bottom, best example I will take it for you: sodium, lithium and the sodium. If you go for the lithium case and if you go for the sodium case, lithium, sodium, potassium, rubidium and cesium, we used to see in the group 1 elements. Lithium atomic number is 3, sodium atomic number is 11. Done. Clear? Lithium 3 protons and the 2 shells. K shell can accommodate 2 electrons and L shell can accommodate 1 electron. Up to now it is clear. Now comes to the sodium case. Sodium 11 protons, 1, 2, 3, 4, 1, 2, 3, 4 and 1, 2, 3. Total 11 protons. And how many shells will be there? First shell can accommodate 2 electrons. Done. Comes to the second shell. Second shell can accommodate how many? This is K. K shell can accommodate 2. Next comes to the KL. L shell can accommodate how many electrons? Total 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Total how many electrons it has happened? Count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But extra electron also we have to add, because 11 is atomic number. 1 electron extra we have to add. That 1 extra electron will be added in the which shell? New shell, right? That is KL M shell. Clear? 1 new shell will be added. Here 1 new shell will come. Clear? 1 new shell has been came. If the new shell, the last electron of the sodium is adding in the new shell, right? See, compared to the lithium we are having only 2 shells. But sodium we are having how many shells? 3 shells. Compared to the lithium, sodium is having the higher size, right? Compared to the lithium, sodium is having the higher size. 2 shells. That's the reason from the periodic table, when we go from the top to bottom, atomic size will be increased. Left to right, atomic size will be decreased. Okay? Clear? Now, next, we are going to move the valency. Sir, what is the meaning of the valency? What we are going to see in the valency? Valency means, for the left to right elements or second period elements, if you see, how many electrons that will be participated in the bond formation is known as a valency. Here see, which can donate or which can accept or which can share is known as a valency. See, better we'll go with the second period elements. Lithium, next one, beryllium, boron, carbon, nitrogen, oxygen and the fluorine and the neon. Clear? These are the second period elements. So if I ask what is a valency? Valency means how many electrons are there in the outermost shell. So lithium, this is a nucleus of the lithium. Lithium contain how many shells? 2 shells. Lithium contain 2 shells, right? Because one is a K and one is a L. K can accommodate 2 and L can accommodate 1 electron. So outermost shell is a valency shell. For the lithium, this is a valency shell, right? This is a valency shell. In this valency shell, how many electrons are there? That many electrons is the valency electrons for the respective atom or the element. For the lithium, only 1 electron is present in the valency shell. For the beryllium, 2 valency shell will be there. 2 valency electrons will be there, so 2. For the boron, valency electrons are 3. For the carbon, it will be 4. Nitrogen, it will be 5. For the oxygen, it will be 6. For the fluorine, it will be how much? For the fluorine, it will be 9. For the neon, this is the octet. Every element want to try to the octet, right? To attain the noble gas electronic configuration. Clear? 8 electrons. Done. This is known as the valency. So based on this valency, how it will share, how it will donate, and how it will be accept. Now we'll see how this valency electrons or valency will play compared to the sodium. What I said, first every element or atom or compound try to attain octet or duplet electronic configuration. Duplet electronic configuration is helium. Only 2 electrons are there. Now octet electronic configuration is neon, argon, krypton, xenon, radon. Clear? These are the octet because 8 electrons will be there in this outermost shell. Only 2 electrons are there in its outermost shell is a duplet. So every element, atom or compound try to attain the either duplet configuration or octet configuration, right? Now here what we are going to see here, now first I will go with the sodium. First I will go with the help of the sodium. Sodium, if you take sodium ion, this sodium ion, if I take this sodium ion contain, what this sodium ion contain? Before it is 11 electrons, 11 protons and 11 electrons we have seen. From this 11 electrons, 1 electron has been lost for the sodium, right? If 1 electron has been lost for the sodium, it has reached to the 10 electrons. 10 electrons will be represented as the neon, means it has reached to the noble gas electronic configuration. It has reached to the noble gas electronic configuration, right? Now, means this sodium by the loss of electron, it has reached to the octet electronic configuration. So, Na plus comes to the Cl minus. Cl by taking 1 electron, it will reach to the octet electronic configuration, right? It will reach to the argon electronic configuration. You can see sodium, its valency electron is 1. It is ready to lose the 1 electron or it is ready to donate the electron. Cl, if it is taken the 1 electron, it will reach to the argon electronic configuration. So it is ready to take the electron. Now these two will combine. And it will form the one stable compound, that is NaCl. Clear? This is one stable atom or this stable ion. This is also one stable ion. Due to this force of attraction between these two charges, it is forming a one stable compound. This stable compound's octet has been completed. Next, here we are going to see with the another one. What we are going to see with the another one? Here, better you will take with the chlorine case. Chlorine, normally its valency electrons are 7. Done. Another chlorine is also there. This chlorine, to complete its octet, it requires 1 electron. This chlorine, to complete its octet, it requires 1 electron. So what this chlorine and this chlorine will do? Mutually it will share the electrons. And it leads to give the Cl2. In this manner, the bond will be formed between the Cl and Cl. See, 1 electron of this Cl and 1 electron of this Cl will be mutually sharing between the two chlorines, right? Means one bond contain how many electrons? One bond contain 2 electrons. You have to remember. This is a first basic. One bond contain how many electrons? One bond contain 2 electrons. These 2 electrons are mutually sharing between the two chlorines. Clear? Now, next, here we are going to see important periodic property, that is atomic size. Already I explained you very clearly. What is the meaning of the atomic size? Left to right, atomic size decreases, and top to bottom, atomic size increases. So next we are going to see metallic character and a non-metallic character. So what is the meaning of the metallic character and what is the meaning of non-metallic character? Now I'll explain here. Listen carefully. Here, when it comes to the metallic character and when it comes to the non-metallic character. So what is a metallic character? Metals. Group 1 and the group 2 elements are the metals we used to say. To be any element to behave as a metal, what it should have, what the tendency it should have to behave as a metal. First tendency to behave as a metal means it should ready to give the electron, ready to give the electron. If any element or atom, if it is having tendency to give the electrons, those will be behave as a metals. Now you see sodium, it is having the 11 electrons. If the sodium, if it is lost one electron, it will get the positive charge. Now by loss of the one electron, it has reached to the octet electronic configuration 10 electron. So that's the reason sodium is behaving as a metal, one which ready to give the electron, so that it will reach to the octet electronic configuration. That's the reason sodium is a metal. Comes to the magnesium. Magnesium, by the loss of 2 electrons, it will readily, it is giving, so that it will reach to the octet electronic configuration of 10 electron. Octet electronic configuration, how the 10 electrons? Neon you can take, amma. Neon is 10 electrons, right? See, 10 protons will be there and the 10 electrons will be there. So neon electronic configuration, everything want to attend to the noble gas electronic configuration, right? Clear? This is known as a metal, the one which is ready to give the electron. Now comes to the which one? Non-metals. Comes to the non-metals. Sir, which are the non-metals? Non-metals is nothing but readily accept the electrons. Which are the non-metals? The one which readily accept the electrons are known as a non-metals. Example, oxygen. Oxygen, it is having the 6 electrons in it. If it has taken the 2 electrons, it will be converted into O-2. Means it has reached to the octet electronic configuration of the 10 electron. Done. Now F minus, by taking F by taking 1 electron, it will reach to the F minus, and it is having the 10 electrons. Now you can see fluorine, by taking the 1 electron, it is reaching to the octet electronic configuration, and oxygen also, by taking the 2 electrons, it is reaching to the octet electronic configuration. Done. Means the one which readily accept the electrons are known as the non-metals. The one which readily give the electrons are known as the metals. Clear? Now I hope almost all the basics of to understand to become the pro in the chemistry already I was covered in this summary lecture. I hope you have enjoyed, and see you in the next class with the other lecture. Okay.